Good morning, fellows. Today we are going to see how Route 53 works in Amazon. Route 53 is Amazon's service for DNS. We will see how Route 53 is useful in as a service and what are the different components that are necessary to make up Route 53 service working properly. What is the endpoints that you can configure, whether we can register the service directly or not, or do we have to go with some third-party registrar and then forward the traffic to Amazon or not. So let us go ahead and see what are the different things. Route 53 forms the part of the networking group of service Amazon offers, and we have already seen how VPC works, how an ELB works, and then finally now we are going to see how Route 53 works and how to configure it. So for people who might not be familiar with what is DNS, the simplest explanation is here. Simply a DNS translates a domain name to an IP address, and that IP address is directly points to the web server or S3 location or a load balancer location. So because people cannot remember different IP addresses when they are trying to reach a website, so it is more easier to remember a name. So then you need a service that will translate the name to an IP address. So that is what is a DNS resolver, and usually the DNS resolver will be cached in multiple locations so that the load is distributed across multiple resolvers. And whenever you get a response from a resolver itself, there's a cached location or a slave, DNS slave, it would be a non-authoritative answer. But whenever you go and ask the main DNS server itself, you get an authoritative answer. So that is how DNS works, and then DNS resolvers are there in between you and your endpoint or a server that is serving the web pages. So the DNS service that Amazon offers, Route 53, also functions in a very similar purpose. That is, you give a domain name to the DNS resolver, and then the DNS resolver will give you back the IP address, and in turn the IP address will be pointed to a S3 or a load balancer or an EC2 location. It could be any of those endpoints. Route 53 can work with. So,
Excuse me, Kumar.
In addition to performing a DNS service, Route 53 also works as an health checking service. And what I mean by the health checking service is it can check whether your endpoints like EC2 instances are available or not. If it is not reachable over a particular URL or a particular IP address, it can trigger a notification to your CloudWatch to say that the server is offline, take some corrective actions, or send the traffic to somewhere else. So it performs as an health checking service as well. If you remember, ELB also can do health checks. Autoscaling also does health checks. So you can have health checks in multiple ways for your instances or resources in AWS. So apart from being health checking, it is also a highly available and scalable service because as the traffic increases, Route 53 also scales to meet the traffic. So you don't have to spend time to configure your DNS to scale according to your traffic. Automatically, Amazon takes care of those responsibilities. And it is also highly available as well because you can configure it in multiple to send the traffic to multiple regions, multiple resources, or depending upon the architecture, you can send it to a static website hosted in S3 or to a CloudFront location. So you have plenty of options and flexibility to set up your architecture so that even if your server which is serving the web traffic is not available, you can send them or send the visitors to the static website to keep them engaged with your account. So those kind of options are available to ensure that the service is highly scalable and also available. And let us go ahead and see what other services are available. So Amazon gives you a guarantee of close to 100% SLA for Route 53 because the reason is you will not see this number in any of the other services. The reason for that is your DNS is the entry point for your digital kingdom. So if your DNS is not working, people cannot reach any of your services that you're offering unless they can remember the IP address of the service that you're offering. So Amazon gives a guarantee of a high availability, and that is a close to 100% SLA for Route 53 when you sign up for them. And we already saw how the health checks and failovers are important for a DNS service or a Route 53 service. In addition to those two important features, it also offers advanced routing facilities. When I say routing, it is you can think of it as a comparable to a load balancing or a traffic management policies. So there are three common traffic management policies offered by Amazon. One is a GeoDNS, that is a geography-based DNS. So if a person coming from Europe, the request is coming from Europe, you send it to the European data center or European regions. Or if the person is coming from India, you send it to the India-based regions in Mumbai region or the nearest one like Singapore. So based on the region the request is coming from, you can route the traffic to the nearest region. And then next is LBR, that is load balanced routing. That is what I think it is. Just give me a moment. I'm sorry, it is latency based routing. That is what LBR means. So if a request is taking, say for example, 500 milliseconds to respond to, then Route 53 finds out what is the nearest service that can offer lower latency, then it will reroute the request to that location. So depending upon the latency, you can forward the traffic to a particular destination or a particular endpoint and make sure your customer is not having a high latency and the user experience is not impacted because of very high latency. So then there is a weighted round robin. Weighted round robin is nothing but you can have a complex mathematical formula to take measurements from multiple health check reports, latencies, geographical location, and find out what is the weightage for that person. And then when I say person, the request, and then you say which is the best place to send that request to. So it is a very dynamically calculated response. So you can do a lot of traffic management of activities in your Route 53. It allows you to do complex calculations and find out what is the best way to handle particular traffic and then reroute the traffic to that particular location. Say for example, if you're looking for download a very big image or a very file item or object which is a very big in size, that means that you are ready to wait for some time until the object is going to load. So I might not need to provision you with the highest bandwidth available or a fastest bandwidth available. Probably I will send you to a server or a machine which has the highest throughput available. Whereas somebody is looking for loading some small amount of images or text which needs to be loaded very fast, then I will send that request to a server or an endpoint which has a very high latency or very low latency response. So depending upon the scenario, I can send the request to the appropriate endpoint, and weighted round robin helps you to do that. And in addition to the above, Amazon allows you to do alias records to your AWS resources. What it means is you can point your Route 53 directly to your S3 buckets or any other aliases that you might have created in your AWS account. It could be in, that is how your EC2 comes in. You can point it directly to your EC2, or you can point it directly to your RDS, that is a database endpoint. Any endpoints that you get, or even in EFS also you can point it. So you can have any of the resources point to in alias through alias records. Then finally, there is a very interesting concept of private DNS or the split horizon DNS is there. Sometimes I've seen an interview question on what is a not interview one, what is an exam question on split horizon DNS. What it means is if you want to test out how your DNS is going to perform to the external world, you need to test it. But testing DNS is a tricky aspect because once you put up your DNS server and it is available to forward traffic, then it is going to serve internet traffic or allow your servers to be seen outside. And you cannot have two DNS names for the same server. So you need to isolate your group of resources and test it properly. Means you need to have private DNS. That is how the split horizon concept comes in. So you isolate your completely all the resources that you are going to test it and the DNS names that you are going to test it, and register that particular name in your AWS Route 53. And this traffic is completely isolated from the outside world. so that you can have something like a www.abc.com, even though abc.com in the outside world might be something different. Internally, a server a.abc.com might point to some S3 location, and server b.abc.com might point to an EC2 location or anything like that that you can configure. So you can have a completely private DNS which is not visible to the outside world and do some performance testing or latency testing, anything inside your servers. And finally, there is another important service that Amazon offers is a domain name registration. You can register your domain names through the Route 53 service itself. You have the control panel to search for domain names and then register your favorite domain names. In my opinion, it is little costlier than what the outside market offers. Since the domain name registration doesn't mean anything additional to that, there is no additional service or anything provided, I would strongly recommend you to register outside and then forward the traffic to AWS itself. Because here you get it for something like $10 to $15, where outside you can go ahead and get it for something like $1 or $2, depending upon the name. Of course, more important words, like if you go and try to register something like google.com, you might not get it, but a variation of that might be very costly. So moving forward, Route 53 supports all these different types of record types. If anybody is familiar with some of them, they will know that this is the A record. A record means the domain name directly points to an IP4 IP address. And if we are talking about four A's like this, that means that the domain name is pointing to an IPv6, that is a 6-octet IP address. That is new concept, IPv6 version 6. This is IPv4, so you get the 4 octets. And then MX record is nothing but the mail records. You can point your Route 53 to work as an email server or an SMTP server. So you need to configure your MX records there. And then when you are talking about the name servers, that is NS, you can create your own DNS servers by creating the NS records inside your Route 53 service. So pointer records and the statement of authority, these are all for DNS services itself and for email services. So when you have a statement of authority, then your emails forwarded by your email server will be considered as an official server, not somebody spoofing it, so that your ISPs will land your email addresses in the inbox instead of spam mails. So SPF or SRVV, these are other records that are available, text records. These are not most commonly used. Whereas when it comes to CNAME, it is again another alias service provided by the DNS service itself. Apart from the AWS alias, you can also configure CNAME alias. Your CNAME can point to an A name, in other words. So you can have something like www.abc.com is your A name. Something like intranet.www.abc.com can be your C name. So people inside your organization can have an intranet website, which is also part of a subdomain of abc.com, and you can have a nice fancy name for that and point a C name to it. So when somebody says a C name, just think of it as an alias to another A name record, and C name can never point to an IP address ever. So just remember that. And these are all DNS concepts. If you're a little bit unfamiliar with this, I would strongly recommend and go ahead and check out in Wikipedia. There is a lot of fantastic information on Wikipedia regarding this. So what I was saying is, We are going to see how health checks are configured in Route 53, and you can configure Route 53 for different resources like EC2s, RDS, and S3 packets, and it is configurable for having the intervals as well. There is no hard and fast rule on how much time you want to spend on configuring the intervals, or if you want to check it every second, every 5 seconds, every 10 seconds, all those things. It is completely customizable. And what I have seen is most probably people do a very basic health checks with Route 53, not intensive health checks, because the intensive health checks are done through some custom scripts or CloudWatch scripts itself, not through Route 53. But if you are short of health checking options, then go ahead and configure Route 53 also to do the health checks for your resources. And it is also possible to configure health checks for non-AWS resources also. That is also possible, but I have not seen this happen in real life. But just to be aware that this is also possible. So you can try to reach out an endpoint, say which is outside your AWS service, and it is in the corporate data center, and see whether the response is coming back as a HTTP 200 or successful response. Then based on that response, you can take some corrective actions or um, preventive actions. So that is also possible with Route 53 service with regards to health checks. So this is a logical configuration of how the health check works. On the left hand side, you have your database server, you have your web app server, and then you have a Route 53 pointed to your primary, and then you have a static website in the S3 bucket configured. And currently you can see the primary is active, the health check is also active, so the secondary traffic is not happening. So this is what I'm talking about. The secondary is inactive, whereas your primary, that is here, this is serving all the traffic here. So for some reason you find that the health check is the server is going offline, and the server health check has failed, and it has been marked as unhealthy. So what happens is your secondary becomes active, as you can notice here, and then the Route 53 informs the cloud formation, not cloud formation, cloud watch, or an auto scaling group to take the corrective actions. So once the corrective actions are taken, automatically what happens is that the server will be rebooted, restarted, or created another instance, and then the traffic will fall back over to the primary location itself. So meanwhile, your customers are visiting a static website. Instead of getting a page cannot be displayed, or they are engaged in some other manner where they don't feel that the service is unavailable or some problems with the servers. So this is how you reduce the impact to your customers. Although your primary site is down, but you reduce the impact to your customers by having a secondary site, which might be even a static website, but still you can keep your customers engaged until you have time to fix the problem and come back online. So moving forward, you have complicated health checks. As I said, you can have a combination of multiple health checks using the and or not parameters. As I said, you can have latency measurement based health checks also, which measure your performance in addition to your availability. And your CloudWatch also, if you we have not seen CloudWatch, but we have seen it in the ELB. If you remember, there are a number of healthy instances, unhealthy instances, the latency time that amount of time it requires to serve the request, and also how many errors were there, either 404 errors were there, 200 codes were there, what is the response codes. So you have plenty of these metrics. You can have the metrics to be measured like CloudWatch by saying that if there are more than 100 404 page cannot be displayed messages responded by my Route 53, then take some corrective actions to change the endpoint. Those are just simple scenarios, but your customer might come up with their own scenarios or ask you to come up with a different kind of a metric for their system. So you can calculate health checks based on what is important to your customer, whether latency is more important or availability is more important. So you speak with your customer, talk to them, understand it, and then choose the appropriate health checks for your customers. So that is how you set up complicated health checks. Either you calculate it or just take a latency measurement, which is a combination of multiple things. And the most simplest of routing is we already spoke about it, just one-to-one mapping. If you get a request, you just have two resources at the back end, send it to each one of them one at a time. So that is a simple routing policy that you have, a simple round robin. Whereas when you want to have complex routing policies, then you have this weighted round robin or latency based or geolocation based round robin. The most common thing is people do simple routing unless the simple routing is inefficient or not satisfying the customer requirements. That is when I see people going through the three options that is listed at the bottom. Say if you are a web scale company like Google or Facebook or YouTube, then you start looking at some of those things. But if your endpoints are going to be hardly 3 or 4 servers, then there is no point in having a geo-based routing or a weighted round robin, because at the end of the day you need to route the request to 3 servers only. So there is no point in having a complicated routing policy set up there. So it depends upon your architecture or the endpoint that you are working with, then you can use the appropriate routing policies. And my recommendation is start with simple routing. If your endpoints are very small numbers, then you slowly start figuring out how to use weighted round robin on latency based. So let us go ahead a little bit deeper and see what is a weighted round robin. So you can see here in weighted round robin, you have a weights for a given resource. When I say weights, the weights are identified based on different types of metrics, the CloudWatch metrics or ELB metrics, and you give weightage to each metric in a different ways. For example, if you don't want to see any amount of failed request, so you give more weightage to the failed request, and latency gets a secondary weightage, and then your healthy instances gets a third weightage. So you can have weights for multiple things, and then you sum up the weightage, and then you use this formula weight for a given resource set by the sum of the weights. So out of let us say you are measuring 5 different items, and then the maximum score that you can get is something like 25, and then you get a score of 20. So you divide 20 by 25, and then you get a 0.2. So point 2 means you send it to this endpoint, point 3 means you send it to this point, 1 means you send it to this endpoint. So you can have rules like that configured in your Route 53. So it requires some advanced understanding of your resources, what resources are important, what metrics are important, and then you do the routing based on weighted round robin. And latency based, we already spoke about it. Uh, if a person is sent to the region which is nearest to that person where the request is originating, then the latency is going to be reduced because the number of components between this person and the region that is serving the request will be lesser. Or you can have if the request, you can try to understand what is the request, whether it is a request for a static website, static object, like for example, the person might be requesting for an most wanted video which you might have cached in your CloudFront. So you can send the request to your CloudFront endpoint, so the latency is reduced. Or if the person is requesting for a completely dynamic page which gets generated, auto-generated every time the person comes and visits, say for example your news feed, or say for example the homepage of news.google.com, it gets generated every time you visit it, or at least most of the components gets generated every time you visit it. So those components alone will go to your EC2 or an application server, whereas the rest of the components which are pre-generated will come from your static websites like S3 or your CloudFront locations. So your latency can be improved by combination of these kind of things. So depending upon what your application is requesting, you send the request to appropriate locations. And for latency based routing, you have this different endpoints that are already supported. You have your EC2s, you have your ELBs, both are available as an endpoint for your latency based routing. Geolocation, I don't even have to talk about this. We did speak about this plenty of times. Send the person to the nearest location where the request is coming from. That is what a geolocation based routing means. You can configure routing for each and every country, or you can configure it at a region level that Amazon has identified, or you can forward all traffic to one location also. So you can have fine-grained granularity, or you can have mass groupings also. Something very similar to this, if you remember, we did it in CloudFront. We try to deny or allow access based on the person coming from. You can do the same thing in Route 53 also. You can have deny or allow access. So here's the thing that I was saying for the granularity. Sometimes for certain continents, Amazon allows you to do it at a continent level, country level, or even state level. So depending upon where your request is coming from, you should be able to achieve greater amount of granularity and send the request. So that is what geolocation based routing allows you to do. So we spoke about this private DNS or split horizon DNS. So you can configure Amazon Route 53 to manage your custom DNS names. You can have your own google.com inside Route 53 because the traffic is going to be handled completely inside your Route 53 service. And then you can check whether your DNS changes are propagating nicely and your applications are working fine with your DNS services. And you can have both your internal and external versions of the working website working fine with the same IP addresses and the domain names without impacting the other. So this way you will be able to test your application in real world scenarios rather than having a mock-up scenarios. So split horizon is mainly for testing purposes of your real world application architecture setup. You can have the same domain names, same routing policies, everything set up and see whether it is working or not. So apart from that, we don't have any other reason for having a private DNS. Or if you have a very secure or an environment which requires a lot of compliance controls. Say, for example, they don't need to be accessible from the internet, only from your corporate intranet. Then you can set up a private DNS which extends to your corporate intranet to your Amazon services. Then there is one more use case I can think of where you will set up a private DNS, but mostly it is used for testing purposes only. Alias records, that's an interesting concept because you can use an alias record for your S3 bucket. You can use an alias record for your CloudFront, and you can have an alias record for your load balancer. So there is plenty of options. You can create alias records. These are very similar to the CNAME records that a DNS service provides. That is at a DNS level, whereas alias is at an AWS Route 53 level. So with the combination of these two aliases and CNAMEs, you can achieve a lot of flexibility in the type of endpoints that you can get. At the bottom, you have an example here. For example, your customer has an alias record pointing to a load balancer. If the IP address of the load balancer changes, Amazon Route 53 will automatically reflect those changes without any changes to the hosted zone, or meaning your alias records will automatically recognize the changes in the endpoint and forward the traffic appropriately. That is the functionality of the load balancer. Also, a load balancer gives you an endpoint as well as an IP address, but it is ideally good to use the endpoint or load balancer's ANAME record, so that even if the underlying server or something changes, the load balancer will still point traffic to a new server with a new IP address or a new endpoint with a newer IP address. Your customers will not have any difficulty in continuing the activity they're doing even when the endpoint changes. So that is how alias records helps you. So you don't have to worry about what is in the front end, or what is at the back end is changing. This I'm not going to talk about. DNS registration. People should be familiar with this. If not, go to GoDaddy, because the DNS registration is nothing but if you want, say for example, www.abc.com, you just go and search for it and find out what you like it. If you like it, go ahead and buy it. There's nothing much to it. You can have a top level domains. You can have a subdomains. You can configure anything. It is better, in my opinion, at least for this service, at least to go to GoDaddy or some other third-party service and come back and register it. So today, this is the demo we are going to see. First, we are going to set up a private hosted zone, and we are going to create two instances and try to ping each other through their host names. Not ping, we are just going to try to access them using their host names. That is a host name that we are going to set it up ourselves. And then after that, if we have time, we'll go ahead and set a public hosted zone, and then we'll point it to a CloudFront location or an S3 bucket, and also see how to set up a load balance policy and how to set up a zone record or how to set up a WW record. That's the demos we are going to see right now.